Right, so we've got our transformation rules, 6 of them really. Shall we just pop them down over here? And we've got the function x plus or minus a rule. We've got the function x plus or minus a rule. We've got the minus function x, the function minus x, and also the function kx. So actually 7 there if we count, 7 rules then. And we're now going to look at the sort of question that you get in the exam. Now, they may be related to an actual equation. They often are related to just a function that is made up of bits. In this case, it's a series of straight lines comprising a trapezium, but it's still a perfectly good function, because if you give me an x value, I can tell you the y value, and clearly this particular function is only defined between -1 and 4. Now I'm going to attempt, I should probably get in a bit of a mess with this, I'm going to try and put as many on this same diagram as I can, but we may have to redraw this one. Usually, again in the exam, you'll be asked to draw the transform function on top of the other one. So the first one then, nice and easy, function x plus 1, that's a translation, it's one of these. Remember, it doesn't go the way you want it to go, it goes back 1. So therefore, the whole thing, this is 0, will go back to there. Let's do it just sort of dotted for a minute. 2 will go back to there. 4 will go back to 3. So this line comes across there, and that stays like that. So the whole function then moves back 1. Number 2. 2 times the function of x. That's our stretch. A stretch, oh in fact I haven't written it down over there, have I? So there is another one too. Let's pop it down. K function x. You might have spotted that when I did the list. So a number in front is a stretch like this. There's nothing below the x-axis, so it's all being pulled up by a scale factor of 2. Now remember the concept of invariant lines. So the x-axis goes nowhere. So this goes nowhere, this goes nowhere. Along here, my y value is 2. Times that by 2, it's going to go up. Let's make that a bit higher. It's going to go up to 4. So all of that bit moves up to there. Everything else is taken up proportionately, giving me a graph that looks like that. Okay, so that's this one. Number 3. Now, let's go back to the yellow. Now this one, remember, this is the tricky one. This is a stretch by 1 over k. So a stretch by a factor of 1/2 parallel to the x-axis. So everything comes in. Nothing happens in the y direction, everything comes in. So this point here comes in to there. This point goes to there. So that line goes like that. This point comes to here, and so the final graph is like that. Okay, now I'm in trouble, aren't I? I've got quite a lot of lines on there, so we'll have to, I think, well, let's just try draw in the answer only and see if we can get away with that. Function negative x, one of these. Remember what that was? It was a reflection in the y-axis. Now when you've got things that are both sides of the y-axis to start with, then they swap over. So that this goes across to -4, this goes across to 1. 2 goes across to -2, and then the whole graph is the mirror image in the y-axis. So therefore, most of it's this side instead of the other. So there can you begin to see then how these rules are put into practice with this type of question. Not too difficult, just remember very clearly what each one does and then apply the rules step by step.